apply the parallel computing on machine learning algorithm, and we will go with the simple machine learning algorithm, and I will give you the different way to apply the parallel computing. Okay, and parallelly I will also discuss about how we have done the parallel computing in the case of neural network, and I will also give you the idea about what are the results we got when we have applied the parallel computing. And if you are working for the parallel computing, then in this case, what is the expectation of the reviewers when you are submitting any paper related to parallel computing, or you are discussing the concept of parallel computing? What is the expectation of reviewers? So what types of results you have to submit when you are working in the area of parallel computing? So these are the outlines for the session. If these are the outlines for the session. So first we'll go through the basic introduction of machine learning. I know you are very much familiar with machine learning, so I will not take too much time for machine learning. Then after that, we'll go for our case study, what we have done during this parallel computing. So we will discuss our data set. Parallelly, we will also discuss about one technique that basically we have used for normalization. And I will give you the reason why we are going for normalization of the data. Next one, we'll go for the different types of validation approaches are there. So how we are using the cross validation approach. Then mainly I will discuss about the neurogenetic approach, means how we have applied the genetic algorithm on neural network with parallel computing. And finally, I will discuss about the results. So what types of results we are getting when we have applied the principal component analysis, when we have applied the rough set analysis, and when we have applied the parallel computing, what types of results we are getting. And finally, we are also comparing with the model. And that time you will get the idea if you are working in the area of machine learning, what is the expectation of a reviewer. And this paper was accepted in one of the good conference called ISEC, India Specific Software Engineering Conference. That is a core conference in the area of software engineering. So due to the time restriction, I'm going to skip the introduction part. Introduction, basically this work we have done for the malware family classification, so I'm going to skip this part. Mainly I'm going to start with the machine learning algorithm. So I think you are very much familiar with machine learning algorithm, because nowadays every company is demanding for machine learning algorithm. So either you are working in any domain, either you are going to join the, means a student is going to join the hardware company or software company, everywhere the expectation is to use the machine learning algorithm. Okay, so if you are going to check the company like Microsoft Research, IBM Research, and TCS Research, in this, in nowadays, they are not encouraging the student to go through the development, because nowadays they are using the LLM model, or you can also call as a chat GPT or LLM type of model, where they are directly generating the source code based on the English language. So once you have the requirement, you can simply fit the requirement and you will get the whole source code. After that, they are using, after that mainly they are motivating the student to check that how we can prove that whether the LLM, whatever the code it is generating, that is logically correct or not. That is logically correct or not. So that is the main motivation behind every company to come in the area of machine learning, because they are not putting the effort for software development. They are not putting the effort for writing the code. They are only putting the effort to check that whether the code is logically correct or not. And that's why if you are going to check the trends like that, every college has opened the branches like data science, machine learning, artificial intelligence, something related to the machine learning. Okay, and here the, if you are going to check the salary wise, also the data science salary normally higher as compared to the software developer. So even for the student also, the demanding area is your machine learning. Why the company are going for machine learning? These are some basic reason behind the machine learning. But nowadays every company start using the machine learning, and here they are facing the huge challenge with the resources. So that the concept of parallel computing and high performance computing will come, because you can only take the benefit of high performance computing if you are going to write your program in parallel manner. So I think that is already covered in the first two or three your session. So what is the objective of applying the HPC and how we can apply the HPC? But if you are talking about the machine learning point of view, these are the main objective, or these are the main motivation behind applying the machine learning. The first one is where they are doing the automatic repetition task. They have gone for the automation. And if you are talking about the automation, means indirectly we are using the machine learning approach. If you are going for automation, automatically the efficiency will improve, and also the third important point, if you are going to check like that, it will also enhance the decision making. Because now if you are going to check, as a human mind we can only find the simple pattern, but if you are using the machine learning, it will also try to find some complex pattern. So that is also one reason behind using this machine learning. And the last one, it will also help to reduce the error, because human has something type of sentiments, because we are also doing some type of partiality with the different types of data. But if you are using the machine learning has no any sentiment, no partiality concept. So in this case, there is very less chances of errors are there. So that's why most of the company, they are moving towards the machine learning, either in the, if you are going to the field like healthcare, if you are going to the field like agriculture, everywhere you will find they are start using the machine learning algorithm. So basically our main objective of this session is to give you the practical flavor of how we can use the machine learning algorithm as a parallel computing. So basically we will discuss about the three different way to make your machine learning as a parallel programming. The one you can split the data. So as for example, if you have already idea, first I'm going through a little bit about the machine learning and then we'll come to that concept. So if you're talking about the machine learning is also similar to your human, okay, similar to the students like that. So if you're talking about the student, we are also following the same machine learning approach. What do we know? A machine learning approach means we are conducting some lecture. So what is the, we are conducting some lecture, and after that we are going to conduct some exam, and based on the exam we are going to check like that whatever the content we have delivered during the lecture, whether the students are getting those types of contents or not, and how we are going to identify by using the exam. So we are conducting the different types of exam, midterm 1, midterm 2, and then we are going for the compre exam, and based on that we are giving one value, we are giving one grade, and that grade basically reflect the performance of the student. That grade basically reflect the knowledge of a specific subject to the students. But the approach is simple. What we are going to do, before starting the semester we have prepared some set of question, few question we are going to discuss during the lecture, and based on that question we are asking some question during the exam. We are not taking the same question during the exam, we are asking the similar types of question during the exam. This is the normal procedure of human learning. But if you are talking about the machine learning point of view, if you are talking about the machine learning point of view, machine learning will only follow the instruction. Machine, I'm talking about the normal machine. Whatever the instruction you are giving, it will only follow those types of instruction. It cannot take their own decision. So, as for example, if you are writing some comment, I'm writing the program to find summation of two numbers. And when you are going to write the expression, that time you are writing x minus y. Instead of writing x plus y, if you have written x minus y. And when you are giving the input, the machine will only calculate x minus y. It will not calculate x plus y. Because whatever the instruction you are giving, whether this is a right instruction, wrong instruction, machine learning will only follow your instruction, and based on that, it will give the idea. They are not using their own mind. But if you are using nowadays a machine learning, it will also check whether you are writing the program for summation of number or subtraction of number. And if you are writing for summation of number, and if you have written x minus b, x minus y, parallelly you will also get some idea, or parallelly you will also get the message whatever the program you have written, that is not for summation, that is for subtraction. So here the machine learning, they are using their own mind. Now the question is how we can make the machine as a intelligent. We will follow the same approach, whatever the approach we are going to follow in the student case, whatever the approach we are going to follow in the human case. Okay, so we'll follow the same approach. What we will do like that, we have to prepare some data. If you are going to check, this is called the training data, and whatever the data we are using during the training, we cannot use the same data for testing. So we will create one data that is called the training data, and after that we will apply different types of machine learning algorithm to find the pattern, means how they are going to distinguish between the car and bike. So basically we are going to design one model, and that model will distinguish between the car and bike, whether this is a car and whether this is a bike. If this is a bike, then it will follow the different types of instruction, and if this is a car, it will follow the different types of instruction. So automatically the machine learning will identify any vehicle, and based on that it will take their own decision. So here the concept of machine learning will come. How it will process? First, we are giving some set of image, and we are using some machine learning algorithm to find the pattern, how they are going to identify whether this is a car or bike. Once our model is ready, now we have to validate that whether they are giving the right answer or they are giving the wrong answer. But we will check on unseen data, we will check on different data, and then we have to check. We will give one car image, and then we will ask whether this image is car or bike. If the machine learning is giving car, then the prediction is right, otherwise prediction is wrong, and we will follow this instruction for maybe the 1,000 images, and based on that we have to decide whether we will go for deployment or not. So this is the overall procedure of machine learning, but you make sure that whatever the data we are using for training, we cannot use the same data for testing. Once the machine learning, you have already validated, yes, the machine learning performance is good. Now the machine is going to be deployment, means now the machine become intelligent, and now it can take their own decision. It will not depend upon the user. Whatever the image it will come directly, it will take the image, and based on that it will decide whether this image is car or bike, and based on that whatever the means procedures are there for car and bike, it will follow those types of procedure. So this is the normal concept of machine learning. First I will go with simple implementation of one machine learning algorithm, and then after that I will discuss about how you can apply the parallel computing on those, machine learning algorithm, and how much benefit you will get if you are going to apply the parallel computing. So first I'm going to share the just one second, I'm going to share. Yeah, okay, okay. So can you please check my screen is visible or not? Anyone, can you please confirm it? I'm showing
Yeah, it's
one code
visible.
here. Okay, okay,
It's
fine.
visible. Thank you.
Yeah, fine, fine. So basically, I'm taking the data for 36 different colleges, if you are going to check it like that. And for every college, we have some features. We are taking the 20 features related to the student. And the last column basically contains 0 or 1. 1 means the student is still waiting for the job, and 0 means the student already got the job. So if you are going to execute this data, we have collected the data for 36 different colleges. So college number one, the number of students equal to 125, the number of feature equal to 20, and the last one your level, whether the student got job or not. How many students got job for college number one? 105. And how many students are waiting for the job? That is your 20. Same like that, that is your college number two. The total number of students equal to 178. Features are almost same in all the colleges. Number of students who got the job 138. And the number of students who are still waiting for the job equal to 40. Same like that, we are going for college number 3. It is showing the what is the total number of student, and out of these student how many students are waiting for the job and how many students already got the job. So simple, the last column basically contains 0 or 1. So our main objective is to apply the machine learning algorithm to predict that whether the student will get job or not. That is our final objective. And after that, if you want to extend it, then you can work for how we can improve the performance of the model. But now we can use some simple algorithm, simple traditional algorithm. So first we have planned to use some simple algorithm, like we have planned to use some type of uh, nib-based classifier. We have to plan to use some simple algorithms. So if you are going to check, we have planned to use multinomial nib-based classifier, Bernoulli nib-based classifier, Gaussian nib-based classifier, logistic regression, decision tree, and support vector machine you can also use. There is no any problem. So maybe we can plan to use 5 different model. So I'm going to write this approach is very simple. I'm going to make the model, and we are going to add model dot append. We are going to add the model. What are the models are there? So we have added these number of models. There is no need to take this one. So how many models we have taken? We have taken the 5 model: multinomial Nebis classifier, Bernoulli Nebis classifier, Gaussian Nebis classifier, logistic regression, and decision tree classifier. So we have taken the 5 different model. If you want to check it, you can check it. Model 0. You can check it. It will give you which one is the model 0, multinomial, which one is your model 1. It will give you the which model we are using, Bernoulli, which one is your model 2. It is giving the value, Gaussian, which one is the model number 3. It will give the values like that, logistic regression, and which one is the model number 4, that it will give the decision tree classifier, because we are using the 5 different models. After that, we are going to define one function. After that, we are going to define one function. But before that, I will give you little bit idea about cross validation approach. Little bit idea about cross validation approach. So whatever we have discussed, if you have remember, I have discussed whatever the data we are using for training, we cannot use the same data for testing. We cannot use the same data for testing. We can always test our model on unseen data, or that data we have not used during the training. So here we are using the cross validation approach. Previously, we are using only the holdout method. Holdout method means 70% data for we are using for training and 30% data we are using for testing. But this is not the right approach, because you are conducting only one time, and based on that you are going to take the decision. If you are going to check the JEE exam, nowadays they are conducting 2 times. What is the reason behind that? Because if you are conducting 2 times, then in this case you will find the best student as compared to conducting 1 time. Because 1 time it may be possible like that a student missed the exam. It may be possible like that the student has not reached the exam center on the time. It may be there are various regions are there in the university system also. We are not deciding the performance of the student based on the single exam. We are conducting the different exam: midterm 1 exam, midterm 2 exam, compre exam, practical exam, and based on that we are going to decide who is the best student. Here we are also going to follow the same app. What we are doing in the k-fold cross validation, we are dividing the data into the 5 different parts, and at a time we can use the 4 part for training and 1 part for testing, and we will continue this process 5 times so that we can get the better result, so that we can find which algorithm is really working best for all type of scenario. So that's why here we are planning to use the k-fold cross validation. So now we are going to define one function that will basically calculate the accuracy of the. So here basically we have to pass the model, and parallelly we will also pass the data. Once you will pass the model and data, in this case it will return what is the accuracy of the model, means what is the average accuracy of the model, what is the average accuracy of the model for this data. Data I have already discussed. In the data there are 21 columns are there. Out of 21, 20 are the feature, and the last one is your label. The label basically contain 2 values, 0 or 1. 0 means the student already got the job. 1 means the student is still waiting for the job. That is the main difference between 0 and 1. So what we have done like that, so first approach, before going to apply the machine learning algorithm, first we have to bring all the feature in one skill. Because if you are not going to bring, if you are going to check the data here, if you are going to check the data here, this is your data. You can see some value, if you are going to check, it is vary between 0 and 1. Some value it is vary between 0 to 0.5. Some value it is vary between 8 to something. If you are going to write here np dot max of data comma x is equal to 0, and you can see here, x is equal to 0, and now you can see if you are going to check some scenario, we are getting very high value of maximum, some scenario we are getting very low value of maximum. As for example, if you are going to check it here, we are getting only maximum value as 4.8, but if you are going to check it here, we are getting the maximum value as 131. Some scenario, if you are going to check it here value, we are getting the maximum value as 7825. Okay. So if you are not going to normalize the data, what will happen like that? The higher value is always dominated over the lower value. When you are going to apply the machine learning, it always give the weightage for those features which have the higher variance, it always give the weightage for those values. So as for example, if you have taken CGP of the student and 10th marks, the model will give more weightage to the 10th marks. If the NA student is getting 60% marks in 10th, and if any student is getting 9.9 CGPA, still the model will give more weightage to 60 marks. Okay, why? The reason is this value is higher, the variance of this feature is high, so definitely they will give more weightage to the 10th marks over CGPA. So before going to apply any machine learning algorithm, we have to bring all the data in one scale. And that's why we have planned to use here minimax normalization technique, because once you will apply this model, this technique, all the data will come in one scale. So as for example, if I'm going to apply here data equal to, if I'm going to write it here, normalized data, whatever the function I have written here, normalized data, if I'm going to normalize the data, normalize data, and here you can see after that, if I'm going to find what is the maximum value, you can see in all the case the maximum value is coming 1. If you are going to find the minimum value, in all the case the minimum value is coming c. So what we have done like that, we have bring all the data between 0 to 1, so there is no any partiality or there is no any concept like that the higher weightage, all have the same variance value. So that is the main reason behind applying the normalized data. So now you can see, now we are going for first approach. We have to normalize the data. So we are writing data all column 0 to -1, because we have to only normalize the feature. There is no need to normalize the label, because label already contains 0 and 1. Once it is done, now we are going to apply the 5-fold cross validation. So we'll get the 5 value of 0. So we are writing ACC equal to NP dot 0. Initially, we are going to assume like that accuracy is 0, because we have not yet applied any machine learning model. So we are going to assume like that the accuracy is 0. Now we are going for training and testing data. Whatever the data we are using for training, we cannot use the same data for testing. So we are writing for TR index, comma ts index. In here we have already defined the k fold kf, so that's why we are writing kf dot split, and here we have write data. So basically it is used to split the data. Once the data is split, we have to calculate what is our training data equal to data of tr index comma 0 to -1. What is our training level equal to this one. So you can see what we have done. If we are going to remember, we have conducted what is our training data and training level, and what is our testing data and testing level. Once it is done, now we are going to fit the model. So we are writing here model dot fit, and here we have to pass our training data comma training level. Once it is done, means model is ready. Now we have to predict the model, and parallelly we will calculate the accuracy. So we are writing here accuracy. Before that, we are going to make I equal to 0, and here we are writing accuracy of I equal to accuracy score, this one. So now you can see after that we are going to return the average accuracy. So we are writing np dot mean of ACC. Clear. So if you are going to check what we have done, like the simple approach we have followed, we have defined one function called ACC model. In this function, we have to pass the model, which model you plan to use, which data you plan to use, and after that, first we are going to normalize the data, and after normalization of the data, what we are going to do, we are going to calculate the data. Okay. If you want to shuffle the data, you can also shuffle it. There is no any problem. So now you can see it is done. Now we have to check whether it is working or not. Okay. From copy, import, copy. Now we are going to check whether it's working or not. So we are going for m in model. For every model, we are going to print what is the accuracy value it is coming. So now you can see I'm going to call this function. Yes. Okay. If you want to print, you can also print m comma accuracy of m comma copy of data. So we are not going to modify the original data. So that's why we have created copy of data. So now we'll check what is the value we are getting here with every model. So you can see it is giving the value. If we are using multinomial naive-Bayes classifier, it will give the accuracy of 59.9%. If you are using Bernoulli naive-Bayes classifier, it will give the accuracy of 68.57, because accuracy we can calculate in terms of percentage. So we have to write it 100. So now you can see it is the accuracy. Gaussian naive-Bayes classifier 57.38, logistic regression 65.37, decision tree classifier 68.61. But the main question is how we can calculate the time, how much time it is taking to execute this instruction. So we'll also calculate the time, and for the time we can use here time model. Okay, to create the time we are going to use here a time model. Okay, so just 1 second. So import time, and we are going to write here how much time it is taking. We are going to calculate the time. So we have to find what is the starting time and what is the ending time. Starting time, and finally we are going to print this one, time dot processing minus start. Okay. So basically, it will also print how much time it is taking to execute the instruction. If you are going to check it like that, it is taking 0.10 second to execute all the instruction, Now, if you plan to apply for all the data, and if you plan to calculate what is the accuracy of the model, we can apply for all the colleges for I in range of 0 to 36. We are working for 36 college. File name equal to file location, this one. Once you got the data, now we are going to apply this value. Okay. Once this one, better we have to calculate the accuracy. So we are going to write here ACC equal to NP dot 0. We are working with 36 different college. We are using 5 models. So that's why we have written 36 into 5. And here we are going to calculate ACC of I comma j. Maybe you can write here for j in a range of 0 to 5. We are working with 5 model equal to ACC model, and then we are going to write it here. Copy of data into 100. So what we have done like that, first we are going to read the data for college 1. Which college you want to read? You can write here print, and here we are writing college I. So for college I, we are printing what is the file location, and once we got the file location, we are going to read the data. Once we got the data, we are going to call the accuracy model, and after that we are passing what is the model number j, and we are passing the copy of the data, and finally we are going to calculate how much time it is taking to execute this instruction for all 36 colleges. Okay. So if you are going to check, it is taking 4.91 second. It is taking 4.91 second to execute the models for all the 5 colleges. And if you want to check what is the accuracy we are getting, here you can also write this is the accuracy you are getting for different colleges. This is for college number 1, college number 2, college number 3, college number 4, college number 5. This is the normal procedure. Till now we have not used any parallel computing. We have simply used sequential processing, and now it is working fine. If you want to use the parallel computing, then simple, we can write, first we have to use one function that is called the multiprocessing. Here we are using one function that is called the multiprocessing. So I will give you one example after that. Multiprocessing, and here we are using the concept called pull. Now you can see these two packages we are planning to use. So first I will give you one simple example, then we can write the program in different variants. So first I'm going to define a simple function. We are defining one summation of two number, and then we are going to return x1 plus y1. This is the function I have written. What we have written, function 1, it will take what is the value of 0, what is the value of 1, and after that it will return what is the value of x1 plus y. Now we plan to execute for different input. Here we have taken the 5 input. This is the value of x1 and this is the value of y1. So what is the summation? 0 plus 1, 1, 1 plus 2, 3, 3 plus 2, 5, 3 plus 4, 5, 3, 4 plus 1, 4 plus 5, 9. If you want to run, parallelly, approach is very simple. You can simply write it here. You can see the approach is very simple. You can write pull dot map. If you're writing pull dot map, here we have written pull and we have to define what is the value of pull. Pull means how many process you want to use. So as for example, here we have written 5. So now we have given like that we are planning to use 5 thread, pull equal to 5 thread, and every thread will execute only one instruction because there are 5 instructions are there, 5 threads are there, means every thread will get one instruction. So if you are writing pull dot map, automatically whatever the input you have given, automatically it will split into the different process. And if you are going to check what is the value of E we are getting, it is also giving 1 3 5 7 9. If you are going to check 0 plus 1 1, 1 plus 2 3, 2 plus 3. If you want to check which process is executing which instruction, you can also print it here. So now you can see if you are writing multi-processing dot current process, it will give you what is the current process and what is the current process ID. We are printing the current process ID so that you will get the idea. Here you can see it had generated the 5 thread with different ID: 12084, 12085, 12087, 12086, 12085, and every thread they are getting the different value of x. If I'm going to write here 2, it will create only 2 threads. It will create only 2 threads. Now you can see it is creating only 2 threads: 188 189, 188 189, 188 189. It is creating only 2 threads. So basically the pull will give you the idea. If you are writing 3, it will create 3 threads. It will create 3 threads. You can see it is creating 3 threads: 737271, and after that again using the same thread 7372. If we are going to check what is the value of A, we are getting the same value of A. But you make sure that how it will work, whatever the inputs are there, you will put in single X. Okay. And that you can input, that you can split it here. You can put in single X and after that you will split it here. Okay. That is the approach. Now we'll see how we can apply this parallel processing in the case of machine learning algorithm. So I have already mentioned there are 3 different ways to apply. The one way I'm going to apply when we are going to split the data. If you are going to remember, here we are splitting the data into the 5 different part. This one, 5 different part. Okay, means this for loop is executing how many times? 5 times. This for loop is executing 5 times. Okay, so why not when we are getting 5 set of data, why not we have to give the individual data to every thread? We will pass, this is the model, this is the data. Now we'll calculate what is the accuracy of the model on this data, and once we will complete it, we will send back to me, and after that we will calculate what is the average accuracy. That is called the data split. That is called the data split. Data split. So what we are doing, we are splitting the data into the 5 different parts, and we are giving each process to execute on this data, and then you will return what is the accuracy of the model. And you already know how we can print this multi-process dot current. You can print the process ID. So now we are going to define one function. We are defining one function, ACC model. And here we have to pass, simply we have to pass the something called aim data, model data. Okay. In the model data, basically the first part it will contain, contain model equal to aim data of 0. The second part it will contain what is our training data equal to aim data of 1. The third part it will contain what is the testing data, aim data of 2. That will basically contain the testing data. So what we have done like that, we have defined the aim data. In the aim data, we have to pass this model, and then we are going to pass the training data. We are passing the testing data, and parallelly, we are going to execute for all the cases. Once we got this idea, once we got the training and testing data, what we have to do, we have to fit the models. We are writing model mod dot fit. We are going to fit the model, and we have to pass it here training data. Once this is done, we have to return the what is the accuracy on testing data. Okay, so this is the function I have written. What function we have written? ACC1, and here basically we will call by using the parallel processing. Now you can see how we can call this model. Now you can see the procedure. The procedure is very simple. First we are going to create one aim data equal to this one. Okay, so first we are, the procedure is very simple. First we are going to create one aim data, and after that we are going to put the value. First we are going to create one aim data, simple aim data. First we have created, first we have created the aim data. Okay, then we are going to put the data. So we are going to write for tr index comma ts index in this one. This is your training data, and this is your testing data equal to data of ts index comma, and then we are writing aim data dot append, and here we are going to pass what we are going to append, copy of model 0. We are planning to use the first model, so we are writing copy of model 0 tr data ts data. Okay, if you want to normalize the data, you can normalize it. There is no any problem, data normalization, that we can use it, but I'm giving one simple scenario. So what we have done like that, if you are going to execute this one, basically it is containing the 5 parts. If you are going to calculate length of aim data, the length will come 5. You can see 5. If you are going to check the aim data of 0, it will contain 3 instructions. The first one, what is the model we are using? If you are going to check, this is the, what is the model we are using? Multinomial. The second one, this is your training data, and third one, what is your testing data? Everything is present here. Once it is done, means what we have done like that, this one, once it is done, we are going to call the same function whatever we have planned to use it here. So now we are going to write it here, pull 5. We are using pull 5. Once it is done, we are going to call this model, this one, and you can see it will start working. We are going to call the model. What are the model we have defined? ACC model, and we have to pass the aim data. We have passed the aim. So now you can see we are using the 5 parallel processing. Now it is completed, and it will return what is the accuracy of the model. This is the accuracy of the model we are getting here. If you are going to write here 100, it will give you the accuracy of the model, but parallelly it is executing. It is not like that sequentially. Parallelly it is executing for every data. The data is split into the 5 different parts, and every thread is getting the one part, and they are executing and they are returning the accuracy. And this is the accuracy we are getting for thread number 0, thread number 1, thread number 2, thread number 3, thread number 4, something like that we are getting. Okay, if you want to print the thread id, you can print it. What is the thread id we are getting? You can print it. There is no any problem with that. Okay, so here what we have done, why not we have to apply for the same thing whatever we have done it for this one. Okay, and then we'll calculate how much it is taking the time to execute the same instruction if I'm going to use the 5 threads. Okay, so again I'm going to use the same processing. I'm going to start with this one, mm, this one. Okay, so first we got the data. Once we got the data, we are going to normalize the data, comma 0 to minus 1, and we are going to normalize the data. So we have to write 0 to minus 1 and normalize data, and here we have to write 0 to minus 1. Once it is done, okay, once it is done, what we have to do, we will go for training and testing split. That code we have written here. Okay, so now I'm going for the same thing. I'm going to copy the same code here, this one. Okay, so first what we are going to calculate here, if you are going to check it here, this is your aim data, training data, and testing data. We are using how many models? We are using the 5 different models. Okay, so we can simply write for j in the range of 0 to 5. Okay, and here we are going to define the aim data for every j. Okay, Now we are going to use the split. Okay. Now we are writing here m data dot append, and here we are writing model number j. So if you are going to check what we have done it here, if you are going to remember what we have done it here, if you are going to check it here, first we are taking the data, we are normalizing the data, and after that we are going for every model. We use 5 models, so that's why we are writing for j equal to 0 means multinomial, j equal to 1 means Bernoulli, j equal to 2, and every time we are taking the different j. Once this data is ready, we are going to call this function by using this one. Yeah. Once our data is ready, we have called the function. You can see here, once it is ready, we are going to calculate what is the ACC of I comma j equal to np dot mean of a. And for better understanding, better we have to write here mm, ACC1 equal to np dot 36 into 5 ACC. So now you can see this is the split. After that, if you want to calculate the time, we are going to follow the same instruction, whatever the time we have given here. This is your starting time, and finally we'll go for the ending time. So that's why we are going to write it here. This is the starting time, and once all the instruction is completed, we are going to print those values. So that's why we are going to write here print time dot processing time minus start. So now I'm going to execute the instruction. We'll check if there any error is there or not. There is no any error is coming. Automatically it is going to complete for all the instruction, and you can see how much time it is taking, 1.72. In the previous case, it is taking how much time? It is taking 4.91, but now it is taking 1.72 second. If you want to check how much time we are saving, 4.91 minus 1.72 minus 1.72 divided by 4.91, you can see this much time, 65% time we are saving. 65% time is, it is more than speeder than this one. You can see it is taking only 36% of the total time to execute the instruction if we are writing this one. This is for a small data. If you are going for larger data, definitely this difference become huge. And if you are going to check what approach we have followed very simple approach. For every, if you are going to check it here, when we are calling the model, here we are passing which model we are using and what is the training data and what is the testing data. So model wise, everywhere it is going the same model, everywhere it is going to the same model, but that their data is different. This is called the data split. So in the data split, we have divided the data into the 5 different part, and we are sending the same model to the each thread, and parallelly we are also sending the different data for each thread. They are calculating their accuracy, and after that they are returning back to the original master thread, and a master thread simply calculating what is the average of all the accuracy, and they are returning back to the system. So this process is called, this process, whatever the process we have followed, that is called the data split. Okay. Now we'll go for the second type of parallel programming, that is called the model split. Why not we have to, instead of sending the data, why not we have to send the different model? Every process will get the different model. Data remains same, but they are getting the different model. Data remains same, but they will get the different model. And after that, they will return what is the accuracy on their own data. And finally, we have to store it. So if you are going to check, this is the accuracy one we are getting for data split. If you are going to check it here, we are getting the similar accuracy here also. Now you can see this is your ACC1 here we are getting, and the second one we are getting here ACC. Now you can see. So ACC1, they are coming approximately same. So when we are running parallel processing, we are also getting the same result. Now the next one we are going for, next concept, that is called the model split. Okay, we have to pass the model, but we have to pass the same data to everywhere. So now we are going to define ACC model 2. Here we have to pass the same m data, but this time the difference is model equal to whatever we have, right, mod equal to m data of 0, and then we are getting data equal to m data of 1. When we will get the data, we are going to normalize the data. Whatever the procedure we have followed here, we are going to follow the same procedure here. Now you can see, I'm talking about this one. I'm talking about the first one. Yeah, this one. We are going to write the same code here. If you are going to check, most of the time we are going to copy paste only the code. So what we have done here, normalize the data. Once the data is normalized, we are going to calculate the accuracy. Here we are using every thread, they are doing their own splitting of the data. Once they have done the splitting, they are going to return the value. But the difference is, this time we are sending the different model to every thread. So now we have defined here ACC tool. The rest of the procedures are almost same. Okay. So now we have to check how it will work in the case of parallel processing. Again, we are going to copy the same code, whatever the code we have taken here. And again, I'm going to copy paste the same code. And this time we have to modify it. So once we got the data, now you can see, once we got the data, there is no need to normalize the data. We are already normalizing there. Now we have to write it here, aim data. And we are writing aim data dot append. Append. You can see what we are appending here. Aim data, and then we are writing copy of data. You can see it. So what we have done it here, if you are going to check it here, when it will execute, when this for loop will execute, if you are going to remember, when this for loop will execute, it will give you this value. After that, we are going to store here, we'll write all column, and then we are going to store here A. So what we have done it here, if you have remember, we have taken the aim data. Previous case, if you have remember, the aim data contain three values. The first one, model, that is the same model for all the threads. Second one is training data and testing data, that is different for all the thread. But in this case, this data is same for all the thread. Only the model is different for all the thread. All the thread is getting the different model. Means thread number 0, that is working for multinomial. Thread number 1, that is working for Bernoulli. Thread number 2, that is working for Gaussian. If you want to check how it is working, you can see it here. I'm giving one simple example here. Then I think your concept become clear. You can see. This is the data we have prepared here. This is the data. Now you can see. If you are going to check here, M data of 0. Now you can see what data is there. It is the different model, decision tree classifier. M data 1, that is the different model. Now you can see, sorry, M data 0, M data 0. So here we have written model dot append and data 0. M, okay, sorry. We have to write it here outside this one. We will not write inside it. So this is the model data 0, multinomial, model data 1, that is the different thing, Bernoulli, model data 2, that is the different thing, Gaussian, something like that. Now you can see I'm going to print the same thing, which thread is executing which model. So you can see here, whatever the code I have written, if you have remember, I'm going to print this one. Now you can see. Then you will get the idea of which one it is printing. So I'm going to write it here. Okay, so I'm printing the thread ID and parallelly I'm printing the, okay, first I'm printing the thread ID and then we are printing what is the model is there. You can see. So in this case, what we are printing, which thread is executing which model, we will get the idea when we are calling the ACC tool. Our data is ready. Now we are going to write this one. You can see what types of output we are getting here. Now you can see. So poll.map M2 and this one. We are going to execute it and you can see what output we are getting. It is working. It is working for that data. It is working. Maybe the CPU is busy for some other purpose, but it is working for the data and it will give you how much time it is taking. So we have written simple poll.map ACC model 2 and this is your ACC model 2. In the ACC model, we are also going to print the value. Okay. So maybe the CPU is busy for some other part. So that's why it is taking the time. So when the thread will execute, it will give the values. Okay. So m data equal to this one. If you want to find length of m data, I will also check. Why it is thinking? Okay, I'm going to check what is the length of the data. 5. Now you can see. Okay, so okay, fine. Str of mod, if I'm going to write, then can we work? Okay, so can only concatenate a string, not the multinomial name based classifier to the string. Okay, so here basically the problems are coming when we are going to print this value. Okay, so better we have to use some other approach to print the value. So I think I have written one case. Okay, so just one second. I'm going to check how we can print it, because if you are not going to print in this case, you have no any idea which thread is executing this one. We are going to write here print, and then we are writing here mod. That is called the model. So that is the running thread. Print, that is the model. Okay, so just once only can not the multi. So maybe somewhere we are getting pol.m data. First we have to check the copy of model number J and copy of data. Length of the model is 5, it is coming. Then I have passed the ACC to M data. Somewhere it is coming the mistake. I will check where the mistakes are coming. Okay, so where we have written ACC model 2, ACC model 2. But I'm not mm, running PhD model 2. Which function it is calling? ACC2, maybe some other name we have given. ACC model number 2 running. Here I have already modified the code. Mhm. Print running is which line I have written? Multiprocessing, somewhere I have written not written. Okay, so Python input line number 2, ACC model 2. Maybe I'm going to change this one to ACC model number 3. Just one second, it is working. I will check what value it is printing. I will check, because I have given here print running, something like that I have given here. Still it is working. It is taking a little bit more time. Okay, so we'll check why it is taking this much time, but it will work. So here we have taken the model data equal to 0, data equal to model name data of 1. Then we are going for current trade running. That is fine. We are going to normalize the data. We have calculated SSE equal to 0. Training data and testing data, we have done it. Model.fit, we have calculated the accuracy score. And finally, we are going for np.mean. Why it is taking too much time? I will check why it is taking too much time, because it will not take this much time. It will give the output. I'm going for pull. Again, we are going to define the pull. Where the mistake list object had not the fit. Okay, so copy of model number J, model J, and again I'm going to define the model, whatever the models we have taken here. So I'm going to check only model J of 0, what value it is coming, multinomial J of 1, okay, 1, 0, Bernoulli. Okay, so now we are going for again M data. It is working fine, but somewhere it is giving Gaussian. It is working fine. Which thread it is executing? List object had no attribute called fit. Okay, so maybe some problem we are facing here. So we have written the mod equal to this one, M data of 0, M data of 1. Then we have taken here. Okay, mod dot fit we have to write. That's why this problem is coming. I've written model.fit. That's why this problem is coming. Now I think there is predict. Again, we have to write mod.predict, not the model. Mod.predict of testing data. So now you can see if I'm going to execute it, here you can see it is also giving the idea which thread is running for which one. Maybe I think I will check now. I will check whether it is working or not. Um, plus str of mod. Maybe it will work. I'm going to check whether it is working or not. ACC model, so that it will come in one line, because parallel it is working. Now you can see it is working fine. So if you are going to check it here, it is giving which thread is executing which model. Thread number 924 it is executing Bernoulli, 923 it is executing decision tree, 922 it is executing logistic regression, 920 multinomial, and 921 it is executing Gaussian naive classifier. So every thread is executing. If I'm going to write 3 here, then only 3 threads will created, and you can see 045 multinomial, 046 Bernoulli, 047 again, 047 and 0545 they are executing the different model. If you are going to check it here, okay, so here what we have done, we have passed the different model to the different threads. Okay, so I'm planning to use the same thing, but there is no need to print the value, because ultimately it will take the time. So after that, I think this one is already, you got it. So how it is working, and this one you already got it. So now we are going to apply the same task here for model number 3, ACC model number 3. So you can see what we have done, like that, model dot append, copy of the model dot j, copy of the data. Then after that we are coming to this one. Then finally we are going for the time processing dot this one. So now we will check whether it is working or not. So again, we have to write np dot array of a. We have to check whether it is working. If it is not working, I will, yeah, it's working. So you can see again, if you are going to execute it, it's taking very less time, 0.77. Try to understand. If you are coming to the first approach without this one, it is taking 4.991. If you are going to check it, this one without 4.91. If I am using the data split, it is taking how much time? 1.72. If I am using the model split, we have divided the model into the different part, then it is taking how much time? 0.77. If we are going to check how much time we are saving, 4.91 comma 0.77 divided by 4.91, this is the time we are saving. 84% time we are saving, only 16% it is taking. And approach is simple. If you are going to check it here, approach is very simple. You can only call pull dot map. Only call pull.map, and which function you want to call, you can write the function name, and what data you are passing to the individual node, that you have to write it. That's it only. So we have to write only two part, pull.map, and after that we have to write which function you want to execute parallelly, and after that we have to write what data you want to share to the different threads. Okay, so this is the overall, I have given you the idea about how you can execute this simple Python code. If you have written the Python code, simple Python code, how you can work for parallel computing, how you can work for parallel computing. Now again, I'm coming to my proposed work, what we have done in my work. I'm coming to that point. So I'm coming to that point here. So yeah, so this is the work I have done. If you are going to check it here, yeah. So basically, there are two types. I have already mentioned there are two types of parallel computing we have done. One is called the training data set parallelism, and second one is called the node parallelism. Okay, so node means basically we are passing the different node. If we are working for neural network, we have used training data set parallel. How we have done like that? We have divided the data into the k equal parts, the same k fold cross validation. Then we are using the scheduler. The scheduler will basically, we have the maybe in this case we have the five computing node. Computing node means threads. Okay, so we are passing this data to individual. Every data means k equal parts means we are dividing this data into this threads, and after that every thread is working with their model and they are giving returning the result. After that we are merging the result, and finally we are going to test it. Now we have also shown, this is a very important. If you are working with the parallel computing, you have to also show what is the time it is taking. If you are going to check it here, how much time it is taking with every computing node. If you have taken one computing node, two computing node, three computing node, fourth computing node, five computing node, how much time it will take. So as for example, if you are going to check in this case, if I want to compare how much performance will change if I'm going to use this one. So as for example, if you have remember this one, we got 0.776. How many we have used pull, we have used, now you can see, we can write it here and we can check with the different pull. If I am using this one, okay, so this one we can write it here. There is no need to write it here. That's why maybe it is taking less time. So I'm writing here 5. If the number of threads equal to 5, you will check how much time it is taking. If I'm taking the 5 computing node, we'll see how much time it is taking if I'm using 1.15 second. If I'm going to reduce the computing node, if I'm using 3 only, then we'll check how much time it will take. We can also calculate. So we will also show the variation of the time when we are changing the computing node. You can see 1.08 means if you are decreasing, it is also increasing. If I'm going to take two computing node, we can also calculate how much time it is taking, how much time it is taking. You can see it will give you the idea when you are changing the computing node how much time it is taking. Again, we have to write 5 here and we will check it here how much time it is taking when we are taking the 5 here. So 0.93, when we are taking 5, 0.93 it is coming. Okay, so basically we have to also represent when you are working for this types of project, or when you are planning to apply the mm, what we can say like that parallel computing, we have to also show the time, how much time it is taking when we are changing the number of computing node. If we are going to check it like that, when we are going to increase the number of computing node, slowly the time is going to be decreased, time is decreasing. And here basically we have used the concept called genetic algorithm. In our work, we have used the concept called genetic algorithm, and we have done the parallelization of genetic algorithm. So if you are going to check, I have also written the algorithm what we have used here for our case. This is the algorithm we have used for our neural network. So we have done the hybrid approach, neural network with genetic algorithm with parallel computing. And parallel computing we have used here training data set parallelism. Okay, so here these are the results we have. Basically we got for PC, rough set, and parallel computing. We have represented this result, training time versus number of computing node. So if you are going to increase the number of computing node, how the training time will change. And this is the algorithm, whatever we have followed here. We have also shown the performance. What is the total performance? How much epoch it is taking to reach to the better performance? We are also representing here. We are also representing the comparison of this model with other model, the existing model, and how much accuracy we are getting. If we are going to check it here, in this case, we are getting the better accuracy as compared to the previous one, because we have calculated the mean magnitude relative error, and the lower value of mean magnitude relative error, that will represent the better result. And here we are getting the better result in all type of scenario. So these are some conclusion we got based on our proposed work. These are some related references are there. If you have any question related to this work, then let me know, because due to the time constraint, I have gone through some simple example. Given you the simple example, but now you can also go for the next one. You can go for the directly data set parallelization. So we are working for 36 different college at a time. We can pass the data, they will calculate for their 5 models, and it will return the output. You can also try for those types of parallelism. Okay, if you need this code, then simply you can put your mail ID in the chat box. I'm going to share this code with you. You can try with your own data, and then you can check how much accuracy or how much time you are saving, because this is simple data. I have taken simple data. If you are going to check the number of sample 160, 200, 300, something like that. But when you are working with 1,000 sample, when you are working with 5,000, 10,000, 50,000, 60,000, then you will find significant improvement if you are using this approach. So if you need this code, I am going to share the code with you. So you can check your
Sir, you can share with me. I'll share along with the
okay, okay, fine,
PPTs.
fine, fine, fine. So I will share with you, okay, and then you can share with uh, participants.
Participants along with the content.
Okay, okay, fine, fine.
See, participants, if you have any queries, you can post in chat box.
Yeah, participants, if you have any query, then let me know. Anyone, any query, if you have any query, then let me know. And the same task you can apply for your own project also, the because the code is almost same. We are not going to change the code. The code remains same, only we have to change the data. If you are going to apply for your data, you can simply put it and you can apply it. There is no any problem with that. Directly you can apply it. So if you have any question, then please you can ask it.
Yeah,
Anyone,
sir,
any
here
question?
are questions. I'll just read out.
Okay,
Venkat Sainath Gupta sir have posted a question. The
okay.
background process also affects the time complexity calculation. How to handle that?
Okay,
Immediately.
that's what I'm saying. That's why I here, if you are going to check the code, I have used the I have used the if you are going to check this one, I have used the time processes underscore time. It will only calculate the CPU time. If you are going to check it, one important concept. Now you can see here, you can see it is giving the time 1 second, 2 second, 3 second. You can see it here 4 second, 5 second. It is working 6 second, but actually it is taken how much time? 1.1 to 2 second. It is giving the CPU time, only the CPU time it is giving. Again, I'm going to share the code so that you will get I think I am sharing, already sharing the code. Can you
Mm.
please check it here? So when I'm going to execute this code, you can see here in the bottom one, it is also printing the executing time 3 second, 4 second, 5 second, something like that. But actually, it is taking 0.95 second. This is the actual CPU time. This is the actual CPU time. That's why we have taken this approach. So I think there is no any problem, because when the CPU is free, that time it is executing, and we are only calculating that time only. We are not calculating the overall time here.
Uh, and there is another question, sir. In the
Mhm.
graph showing time comparison of execution for different number of threads and
Yes.
our compute nodes, what is the meaning of zero thread parent thread?
Zero thread means when we are not using parallel computing. When we are not using parallel computing, that is called zero thread. So zero thread means when we are not using parallel computing. One thread means one is your master node and they have only one computing node. That is called the one thread I have used. Two thread means one is your master node and there are two computing nodes. One your master node, there are 3 computing node. When we are writing 0 means only master is calculating the calculation. They have no any computing node. That's why we have used the term called 0. Means as for example, here if you are executing sequentially, you can use the term called 0. You can use the term called 0 here. Because you are not using any computing node, you are master is only there. So that's why we have used 0 here. Anyone, any other question? Because due to time constant, I have given simple example. Okay, so one more question I'm getting here.
Yes, sir. Extension to previous question on time complexity. Whenever
Yes,
we are running the code, the time complexity values are changing for every iteration. Which value we need to consider?
time complexity is changing for every iteration. I'm not getting time extension of the previous question on time complexity. Whenever we are running the code, the time complexity values are changing for uh, every no, now you can see we are working for different projects. I'm saying like that we are working for 36 different colleges. Overall we are calculating how much time it is taking. Okay, now you can see it is working like the parallel. As for example, if you have used model parallelization, okay, then in this case you are using 5 models and you have used only 3 computing nodes. First time it will float the 3 models. 2 models are left, then it will calculate. Maybe now assume that the first model is taking very less time, so this thread become free. So in this case directly it will jump to the rest of the task. Directly it will jump to the rest of the task. It is not like that at a time we are assigning this 2 tasks to the single model. It is not like that. At a time we are assigning one task to the each model. Once the any model is completed, then it is going to assign the second task. Then it is going to assign the second task, and all are running parallelly. All are running parallelly. Clear? In this case, maybe you will get more impacted if any specific model is taking more time, because we are taking the overall. Once everyone will complete it, then you will get the out. So in this case, if you want to use, in this case you can use the training data set parallelism, because everyone will take the same time. Because whatever the model is taking the same, at the same time it will take for all the data. So that's why I'm saying, if you know like that all the models will get the similar types of time, you can go with model parallelism. And if you know like that is one specific model is taking more time, then you will go with the data set parallelism. Splitting of data set parallelism means every node will get same model, but they will get the different training data. That concept you can use. Clear? I think it is clear, I think. Oh, the
Yes, sir.
overall time. Oh, okay. Right. I got it. So every time it is changing, you can take the average of 5. I got it. I got your question. You can run 5 times and then you will take the average of 5. I have also taken the same thing. I'm running 5 times and I'm taking the average of 5. We are not taking the best one. You will run 5 times and then you will take the average of all 5. So same procedure, whatever we have followed for the student system. We are conducting the 5 exam and then we are taking the average. If you want to take, then you can also represent what is the minimum time it will take, what is the maximum time it will take. You can also represent what is the average time. You can represent the statistics, something like that. Normally, we are using the 5 or 10. That is the standard, 5 or 10. Everywhere, if you are working with machine learning, normally we are going with 5-fold, 10-fold, 5-fold, 10-fold, 5-fold, 10-fold. So either you can use anyone, that is the standard approach. But there is no any specific conditions like that. I think in this case they will not ask you the question, so why you have run 5 times. That is totally dependent, but the standard I think we have using 5 and 10. If you are going through the cross validation also, you will get the 5 or 10. Everyone is using, so here you can also use 5 or 10. But I think there is no need to provide the reason why we have executed 5 times. Clear? I got your question, so I think previously I a little bit miss. Yeah.
Yeah, participants, if you have any questions, and we'll take it up.
Yeah, and parallel, just one important announcement. So in NIT Kurukshetra, we are also organizing one a good conference related to the software engineering. So if you are going to check in our site, this is called the ISEC 2025. That is
You can,
related to the
you can
software
share
engineering.
links, sir. You can
Okay,
share
I will
links.
share the.
I'll be sending mail to all the participants
Okay,
for
fine, fine. So
information.
yeah. Right, right. So this is the, I think just only I'm showing this is the conference website. Okay, and the conference date is already announced 2021 and 22, and that is purely related to the software engineering. And there are various types of tracks are there. So maybe the data science challenge, you can motivate your student to participate in this challenge, data science challenge.